G'day everyone, Future Jordan here, editing the video. Just wanted to give a heads up that I do announce this as a beginner-friendly puzzle. However, I think on reflection at the end, it's probably not quite. There's a couple of steps in the middle of the solve that I think would be difficult to find if you've never done a Sudoku, a variant Sudoku, and particularly one with these non-standard region shapes. So you might get stuck. You might need to refer back to my video, but give it a crack. I think if you have a go and manage to get through at least the first steps, you might, if you've never done this kind of thing before, you might get a similar sensation to when you first started solving cryptics and the pennies dropped and it was quite exciting. So you'll see something similar with this, but like I say, halfway through you might struggle a bit, so feel free to refer back to the video. Good morning everybody and welcome back to Pi Puzzles, where today we have another variant Sudoku. I did one of these on the channel yesterday. It was a 6x6. Today 7x7, so we're moving up towards the full 9x9. But this has been ranked as an easy puzzle. It was shown on Cracking the Cryptic this morning. I saw it come up and thought, well, that's one that looks like is worth me trying. And apparently very good puzzle, but also pretty approachable for beginners. So we'll give it a go. Just for those who have not seen variant Sudoku before, the idea is that it has similar rules to classic Sudoku in that you can't repeat numbers in columns, in rows, or in regions, but there are additional rule sets which constrain the numbers further and which often lead to grids like this that have no opening digits provided at all. And this one looks pretty sparse, but in fact there are much even sparser grids than this possible with some of the rule sets. This is a quirky rule set, so I'll explain how it works and see if I can solve it. So it's titled Reliably Unreliable by Sujoyku, and there will be a link to this in the description, and hopefully, if I remember, a link to yesterday's puzzle as well. So normal, irregular 7x7 Sudoku rules apply, as contradictory as that sounds. Normal, irregular. So a 7x7 grid, numbers 1 to 7 in every row, every column, and every one of these regions that's outlined in dark black line. Hence the name irregular, because these shapes are not regular. Now, all cages are relic cages. Now, usually cages in these puzzles indicate that the sum of digits in them is equal to the number in the top left corner. So this would have to be adding to 7. But in this puzzle, it's quite the opposite. It says here, all cages are relic cages. In a relic cage, digits do not repeat, and any combination of one or more digits within such a cage cannot sum to the value in the top left. So that means that explicitly in this puzzle, the 7 cage cannot add to 7, but nor can it have a 7 in it or have 2 digits that add to 7. So you can't do that. So you can't put a 7, you can't put 2, 5, you can't put 1, 2, 4 because they all add to 7. So that is an interesting rule set. And when I saw it this morning, I was kind of aware fairly quickly of how you might start to look at this. So let's go. I'll use that example there. This 7 cage can't contain a 7, so that means that our 7 must go in the 8 cage. But in turn, the 8 cage can't now contain a 1 because 1 and 7 add to 8. So the 1 goes in here. Respectively, you can't put a 6 in here because that will add to 7, so you go 6 in here. I might put it in the middle actually. The 6 can't go with a 2, so over here we must put the 2. The 2 can't go with a 5 in a 7 cage, so 5 goes over here. And 5 can't go with a 3 in the 8 cage, so 3 goes over here, and there's only a 4 left, which must be in the 8 cage. So there we go, we have a triple and a quadruple just like that off the bat. And we're going to have the same thing happening over here with this 6. So we can't put a 6 in here, so there must be a 6 in here. 6 can't go with 5, so 5 goes in here. 5 can't go with 1, so 1 goes in here. Well, 1 can't go with 10, but 10 is not a number in Sudoku. But 1 and 6 is 7, which means you can't put a further 4 because that will add to 11, so 4 goes in there. 4 can't go with a 2 in the 6 cage, so 2 goes up there. And 2 and 6 add up to 8, which can't therefore have a 3, so the 3 goes in there and then 7 goes in there. And then we've got this one down here. And well, this doesn't have the same starting point because neither 8 nor 9 are numbers in this grid. So I wonder if there's a digit. What about, I also looked at this earlier and thought, I wonder if that's constrained. Well, we've got these pairs of digits that can't sum together. So for example, in the 9 cage, we couldn't have 2 and 7, 3 and 6, or 4 and 5 together. Well, okay, that means that from each of those pairs, we've got 2, 6, 3, 5, sorry, 2, 7, 3, 6, and 4, 5. From each of those pairs, at least one number can't be in here. Like you could say, oh, I put 2 and 7 both in here and that's fine. But you can't do that because each of these also has to have one digit that's not in there. So you basically need one of each of these sets in the 8 cage, because otherwise, if one of these does not have a digit in here, it must axiomatically both be in here, and that will break. So, and there's no 1 in these, so the 3 digit here will be made up with those 3 digits, and there will be a 1 in there. Can we, I don't know that tells us that much though. Can we, if I put a 2 in here, that tells me that the 7 must be in here, or conversely, you put a 7 in here, the 2 therefore must go in this cage. But I don't know which way around they would go. The 2 could go here, or it could go in this one with a 7 here. I don't think that's going to resolve itself. I wonder whether, because I think I had a similar kind of thought when I looked at this cage earlier, that 8 can be made up of 1, 7, 2, 6, and 3, 5. They're the ways of summing to 8. So one of each of those digits must be outside. So there's only a 4. Therefore, the 4 must go in here because there's no room out here to put the 4. The 10. Well, I know that there must be A1, A2, or A3, or maybe more, but we can't have no 1, 2s, and 3s in here because a 1, 2, 3 triple here would be too many 1, 2, 3s in that row. I think that's telling me a great deal. One thing with these irregular Sudokus is that you can do some geometrical things where there's certain, I'm trying to look for an example, where you can kind of make assessments of where cells are like unusually restricted in other rows and columns. Well, okay, I think, oh, sorry. Yeah, these two cells have to be the same. And the reason for that is that if this cell isn't in there, it must, in this region up here, it would have to be in one of these 3. And that looks fine, except that now you've got the problem that column 1 and column 2 now have that digit, but this region here hasn't had its digit, hasn't had that digit, and so that would break. So the only way for it to work is for that and that to be the same. Let's give it a color, and that restricts this to a 1 2, and that one to a 1 2, and puts a 3 in there. Oh, and we get a 1 2 3 triple. So well, this is going to be a bit interesting, because we can't have both 4 and 6 in here because they sum to 10. So there must be one of 4 and 6. Oh, but we've got a 4 here. So hang on, there's no 4 in there. There must be a 4 in there. Therefore, there can't be a 6, so there must be a 6 up here. Ah, and the 6 can't pair with a 2 in the 8, so the 2 now does go in here. Okay. Well, we've got also across here 3 4 5 6 7. Ah, that's good, because that leaves a 1 2, and the 2 we've already just placed. So that's a 1. We've got a digit. And the 1 had to have a 7 in here. It's kind of the other way around. It's not so much the 1 has to have a 7, it's that there's going to be a 3 5 pair, one of which must be in here and one out here. So yeah, because if we put 1 6 7, we would be forcing 3 and 5 into here. So so the 7 does go in there, it's not in here, that's a 5 6, and the 5 in turn goes with a 3, so this is 2 3 4 7, and we seem to be on our way. So we've got a 4 7 down here. The 7 can't go with a 3. Also, there's a 1 in here by Sudoku because of this one. My Sudoku skills are probably going to slightly let me down, but we'll see how we go. Now, yeah, the 3 can't go in the cage, so the 3 goes in here. This cell has to be a 1 or a 3, because if it wasn't, then this would be a 3 1, but then we'd have 4 digits here from the digits 1 2 3. So that's a 1 3. Oh, and that may be, well, oh, the 1's outside. I wonder what that means about the 2. Oh yeah, so because I was thinking about 7 can't go with 1 and 2, so at least one of 1 and 2 has to be outside the box. So the 1's there, that's fine. But if the 2 was outside the box, this would be a 1 2 3 triple, and I think I said earlier that can't be done. So the 2 must be in the box, in there specifically. We'll take it out of there. 2 and 4 is 6. No, so now we don't know. What are we left with? 5 and 6. I think we don't know the specific. Oh no, the 6 can't be in here. Oh, well, that would be the easier way. 4 can't go with 6 in its own cage. So there's a 6 in here. So this is a 1 3 6. Of which the 6 is definitely in there. And then we're just left with 2 and 5. And I think that checks out. Okay, so that can't be a 5. Now, this is where we need our Sudoku to actually work. Well, maybe we have that similar trick over here. Those 2 cells are the same as well. So this is a 4 5 6 7. And we'll color them, why not? Well, and the complement to that digit, I don't think I know. Okay, there's probably something by Sudoku I can do here. Well, there's definitely a 7 in there because of the row, so that's not a 7. And that's not a 7 in its own cage, or in its own region as well. So this 4 6 2 5 3, 4, 6, 7. So there's a 7 in there. So there's no 7 in there. We've got a, oh no we don't. There's definitely a 2 at the top there. I thought for a second I might have already known what this is, but I don't think I do. I don't know about 1 star. What am I not thinking about? I think I've used the cages in here as much as I can. I don't think I can do anything with that still. I've got all the digits in here. I can't see how I'm using the 11 because it seems just to have lots of ways that it could be made up, and it's a big number, so it's even less restricted than usual. Definitely a 3 in here. Definitely a 3 in here. Are there any more of these geometry tricks? Can we say that those 4 are the same? I think those 2 are those 2. I think that might be correct. Yeah, because we know in these 4 rows we have 4 sets of the digits 1 to 7, but we also know that in those cells we have 4 sets of the digits 1 to 7, and all of these are common. So those 2 sets are the same, so that is there, and that might actually be what. Can we do this on the other side as well? Okay, this is going to be definitely important. Do I know? Yeah, I know they're not purple. So for the same reason, these 2 cells are these 2 cells. So purple is there. Now we get some traction on the 1, 2 as well. And this can't be purple, green, or yellow, so it is another color. Make it blue. Now, wow, say we get traction here. I'm not. No, this is but that gives me a 1, 2, 3 triple. Well, we could have seen that this was 4, 5, 6, and 7 anyway. One of which is a 7. We get the 1, 2, 3 triple, the blues. Maybe I need to track this one. I'll give this a color and see if we can do anything with it. What should I call it? Red. So we've got the red in this row. I can't say that I even know that. The one, yeah, we don't know what color they are either, do we? I need to think about this 2. There's definitely a 2 in there. I'm back, everyone. I paused there because I didn't want to waste too much of your time, and I have actually kind of realized what I was missing. We have a 1, 2, 3, 6 quadruple over here, so this forces these cells to be 4, 5, and 7, and I think this is going to be important, particularly over here. We know that we can't have a 4 and a 5 together, so there must be a 7 here, or else it would be a 4 or 5 pair, which add to 9. So there's definitely a 7 there, but we also know there's definitely a 7 in here. So that means that in these 2 columns, the 2 7s that will be there are there, and we can't put a further 7 here. So that yellow can't be 7, which simultaneously takes this one out, and so we get that green is equal to 7. and that one's equal to 7. Now with a 7 in there, we do get the 2 in. Oh well, the 2 is now placed in there from previously. 2 can't go with a 6, so there must be a 6 in here, and 6 can't go with a 3, so there must be a 3 in here, so that's a 2-3 pair. This can't be, that can't be a 6 or a 5, because 5 goes with 3, so that's a 4 and that's a 5. And I forgot again to turn off the red pencil marking that tells you what digits are no longer possible, but I'm going to go with it because it makes it easier to scan. So we can just knock out a bunch of things here. That's not 5, so that's not 5. Let's ignore them for a second and just focus on what we would naturally see. So that 1 6 place is actually the 4 there, and then 6 and 5, 3 here. So that earlier pencil marking has all proven to be quite useful. Now we know that blue is not 3, so red is 3. Take the 4 out of there, which places the 4 in there. Yeah, so the red marks make life a lot easier. 3 5 makes this a 6 and this a 5. Down here, 6 and 1. Now I think there's a bit of logic to do probably with the 11 cage still, but let's come back to that in a second. This is a 1 6. We need 3 5 up here, which is placed. 2 3. Actually, I think that 11 cage is going to come to the rescue maybe at the very end. Or is it coming to the rescue now? Maybe it is, because I don't know that we can necessarily solve this any further. So we have 4. So if this was a 1 4, you couldn't put a 7 or a 6, which I think is okay. If it was 2 4, you couldn't put you just can't put a 7 regardless because of the 4 here. So, and the 7 can't go there because of this. So the 7 must go up in the corner, and that might actually be all it takes. In the column we've got a 1 2 pair down here, so that's a 6, that's a 1, that's a 2, that's a 1, that's a 6, 2 1 1 1 2. 2 and 4 is 6, so the 5 can't go here. What do we need? 3 5 and 6. So this can't be a 6 because of this 6. Can't be a 5 because it would add to 11, so that is a 3. That's a 5, that's a 3. We're left with a 6 here. And we need a 5 and a 7. 7 here, 5 here, 2, 5, 3, 2 and 3. There we go. Yes, I did like that very much. 2,040 people have solved that in 2 days. Wow. That's a beautiful puzzle. I mean, I don't know that's entirely beginner friendly. I think there's a few steps in there that were pretty tricky. I mean, I got stuck on something basic with that quadruple there, but I think this business with, I think it's called the law of leftovers, placing those as being the same and those as being the same, that's pretty, I don't think that's beginner friendly. But some really beautiful logic there. It's a very interesting rule set. I wonder whether this might go on to be exploited in different ways. In any case, thank you to sujoyku for setting that. It was indeed a joy to solve. And thanks to you for watching. I hope this was an okay introduction. I'm kind of finding my feet. As I mentioned in my video, I got into doing variant Sudoku during COVID with the rise of cracking the cryptic, and became pretty decent at building variant Sudokus. I've had quite a number of my puzzles featured on cracking the cryptic, and some of them pretty difficult, but interestingly I'm not that great at solving them, and some people say to me, well, you must be decent at solving them if you're building really hard ones. But the thing with building hard puzzles is that you kind of, Sudokus are a journey of discovery as you build them. You don't know exactly what's going to happen, even if you have a seed of a concept. The way that it ends up playing out often it's in that play that you discover some interesting things that you can inject into the puzzle. And of course, because you're kind of building outwards, you're kind of solving a puzzle that's yet to be built. You can stumble into very difficult concepts, and you've got plenty of time to kind of thrash out why something works. When you come and look at something cold, a difficult puzzle cold, I mean, I've tried to solve old puzzles of mine that I've forgotten the logic, and I really struggled. So anyway, that's a long waffle to end the video, but hopefully we'll do some more of these, and back to crosswords, I think, on Friday with maybe the DA. And in between times, maybe actually I might have a go at another out of left field puzzle. They're really cool. So in any case, I'll see you all next time for that video. And of course, if you want to make sure you don't miss it, do subscribe. It's fun seeing the old subscriber to clock up on the old channel. Thanks again, and I'll see you soon.